In this video, we configure basic BGP using the route reflector. In our topology, we've got AS100, 200, and 300. In AS100, we've got routers 1, 2, and 3 paired over IBGP. R2 is paired to router 4 over eBGP, which is in AS200, and R3 is paired to R5 over eBGP as well. What we're trying to achieve is to get a device in the 44.x network in AS200 to connect to a device in behind R5 in AS300 on the 55.x network. The issue we face is that this traffic will have to traverse AS100, which runs only IBGP. The IBGP rules prevent a router from sending an update from a device which it receives from another IBGP pair. So in our case here, we will get traffic, we'll get this update from R4 to R2, which is eBGP, and R2 will pass this update on to R1, which is over IBGP. However, R1 will never pass the update over to R3, according to the BGP rules, IBGP rules. To get around this, we can either create a full mesh where we have an IBGP pairing between R2, R1, R2, and R3. But this is not scalable because if we've got more routers, then we would have to create a pairing for every router which we want to pass updates onto. So to keep our current topology, we will use a route reflector. R2 will receive its updates from R4, and it will pass this on to R1, which is going to be our route reflector, and R1 will then pass the updates onto its route reflector clients, which is R3 and R2 for routes which it receives from both R2 and R3 respectively. So to begin, first thing we do is check our connectivity, our basic connectivity. So R1, we can see is connected to both R1 and R2, so we'll first test the connectivity of these. So we'll check this transport link. So it's 10.10.12.2 from R1, so that's working. Then we check the other link, 10.10.13 to R3. This works. We've also got loopback addresses configured on all the routers. In our IBGP, in our AS100, our IBGP pairings, we will use the loopback addresses as our router IDs, or our router. This is what the routers are going to use for their pairings, and these are advertised over an IGP OSPF running in AS100. So we test connectivity to those loopbacks. And that's working. So we can now go ahead with our basic BGP configuration. Oh, first, sorry, we need to check connectivity as well between R2 and R4 and R3 and R5. So we go on to R2. And that would be .2. And onto R3. That's functioning fine. So we first go on to R1 and configure our BGP. Configure our first neighbor, which is R2. Second neighbor. Okay, so if we go back to our topology, we see that R1 is connected to R2 over the 10.10.12 network. This is our exit or our egress interface on here. This is what our egress interface is configured on. So when router 1 sends traffic to router 2, it's going to use this subnet. Because we configure in our pair as 2.2.2.2, router 2 or router they're going to, and router 1 and router 1 as 1.1.1.1, they will expect the traffic to come from these IP addresses or these subnets. However, router 1 is going to use this egress interface, which is 10.10.12, to send traffic to R2. R2 is going to expect its neighbor. When we configure, you will see in a minute that we configure it as 1.1.1.1. It will expect neighbor 1.1.1.1 to come through on that same IP address. However, it will come on 10.10.12.x, and unfortunately, it will not establish a connection because of this. So, in order to get this to work, we configure the update source as loopback 0, which is configured as 1.1.1.1. So when router 2 receives its messages to try to establish a BGP session, it will receive that information from 1.1.1.1, and then it can then establish the session. So we do the same for router 3. Then we go to okay, we'll have nothing happen as yet until we configure the neighbors. So go on to router 2 and configure BGP. I'll also configure, in fact, no, let's just carry on with this first, IBGP connections. Do the same on router 3. Okay, that should come up. Okay, so we see that the neighbor relationship has come up. If we go, okay, so here we can see our two neighbors which have come up. We've got no prefixes being advertised, so this is fine. So we've got 0 prefixes, and we can see that they're both in AS100. So our IBGP configuration is up and running. Okay, so we go on to router 2 now and configure this link here, our eBGP connection. And we use Okay, onto router 4. Okay, so we've got our EBGP, our first EBGP pairing up. If we go on to router 2, we can see both of our neighbors have come up. And you can see that there are no prefixes because router 4 has not advertised any network as yet. Okay, so we go on to router 5. In fact, go on to router 3 and configure our second neighbor. Wrong one. That'll be AS300. And then we go on to router 5. Okay, so we now have this second neighbor up. All right, and also there's no prefixes. Okay, so we need to advertise this network into AS100. So we go on to router 4 and we go and the same on router 5, we advertise our 55.x network. Okay, hopefully by now this would have updated. Yeah, so we can see that there's one prefix being advertised. So if we show our BGP table, okay, valid and best. So if we do, we can see that we've got one BGP prefix in our RIB. So we should now be able to ping a device in that subnet from router 2. Yes, this is successful. And the same on router 3. Success. Okay, so if we look at router 1, see what's going on here now. So on router 1, we can see that both of the routes have been advertised. However, we don't have a valid and best symbol on here. We don't have a best symbol. So we've got the valid, the route is valid, but we don't have a best. So that means it's not entered into the rib. So we've got no routes here. Why? Okay, the reason being, router 2 has received this update from router 4, and it has passed it onto its first IBGP pair. This is allowed because this update has come from an EBGP pair, so it's allowed to send it to here. So it's router 1's received it. However, IBGP does not change the next hop value by default. So this has sent the update through, and its next hop value we can see on router 1 is 10.20.24.2. However, router 1 doesn't have a route to this network. So it's unable to reach this. So this route is not going to be able to reach router 2. So it will now not even try to forward this route, this update, just because it can't even reach it itself. Okay, so to fix this, we'll need to go on both router 2 and router 3 and tell them when they send their update to router 1 to change the next hop value to themselves. So if we go on to router 2 and we go neighbor, when we send an update to this neighbor, make sure the next hop is myself. And the same on router 3. So we just copy this. Good. If we check on router 1, okay, this hasn't updated. So what we can do is a soft refresh. Declare BGP star in. Yep, so this is now reachable, so it will now be entered into the RIB. Okay. All right, so we've got router 1 now advertising the receiving the routes from both of these edge routers on the edge of AS100, but we still haven't solved the issue, because if we go on to router 2 now, we see that it only receives the 44.x network, which it gets from its EBGP pair, but we also need it to get the 55.x, so it can then pass it on to its EBGP pair. And the same as on router 3, it does not receive the 44.x network. And this is because of the BGP, the IBGP rules, where router 1 has received this update from router 3, which has a pairing, which has got its update from an EBGP pair, but it will not forward the update to router 2 and vice versa. So in order to fix this, what we'll do is implement Route Reflector. So we change router 1, configure router 1 as our Route Reflector. This is a very simple configuration. All we do is this. It would help if we do it on router 1, which is our Route Reflector. So go on to router 1. and here you can see the connection being reestablished, and the same. So session is being reestablished for both routers. Okay, so if we go on to router 2 now, and we do that command again, there we go, success. So we see that we can now receive the routes which we require. So now let's see what happens to the eBGP pairs. Okay, so we've got both routers being able to get those routes. So router 4 and I'd say and router 5 can now get the 44.x network. So if we try the ping now, so if we try to ping from router 4 to router 5's 55.x network, let's see what happens. And I'm expecting this to fail. As expected. However, this does not mean that configuration is wrong. It's only because this is being sourced from its egress interface to its next hop. So the egress interface to the next hop of 10.20.24.1 will be 10.20.24.2. However, this is not in router 5's routing table. It does not know how to get to this source. So the pings actually are sent, but the echo reply doesn't return from router 5 because it's unable to reach the source which it got for this packet. So to correct this, we change the source while ping, and from router 4 our source would be 1, and there we go, success. So this works. So we have now configured BGP with a route reflector. I now encourage you to lab this up on your own and try to get it to work. Please use the like button if you liked the content, or the dislike if you didn't like the content. Also, leave a comment if you wish. And if you'd like to see more videos like this, please subscribe to the channel. Hope this has helped. Thank you.